Hello everyone. Today I'm going to talk about data modeling. What is data modeling? Data modeling is the process of creating a data model for the data to be stored in a database. This data model is a conceptual representation of data objects, the association between different data objects, and the rules. Data modeling helps in the visual representation of data and enforces business rules, regulatory compliances, and government policies on the data. Data models ensure consistency in naming conventions, default values, semantics, security while ensuring quality of the data. There are two types of data model techniques, which are the entity relationship model and also UML, which stands for Unified Modeling Language. So, why do we use this data model? Firstly, it ensures that all data objects required by the database are accurately represented. Omission of data will lead to creation of faulty reports and produce incorrect results. A data model helps design the database at the conceptual, physical, and logical levels. It also helps to define the relational tables, primary and foreign keys, and stored procedures. It can provide a clear picture of the base data and which can be used by database developers to create a physical database. And last one, it is also helpful to identify missing and redundant data. There are steps in which data modeling is processed. The first step is to identify the entities or business objects that are represented in the dataset being modeled. Secondly, identify a key property for each entity so you can differentiate between them in the data model. The third step is to draw a rough draft of an entity relationship model to show the connections between entities. Next, identify the various data attributes that need to be incorporated into the data model. The fifth step is to map the attributes to entities so the model properly reflects the business meaning of the data. And the last step, finalize and validate the data model and then refine it to keep it up to date as the data changes.
Next, I'm going to talk about business rule. A business rule is a brief, precise, and unambiguous description of a policy, procedure, or principle within a specific organization. They are important in data modeling because they set the stage for the proper identification of entities, attributes, relationships, and also constraints. Those are the data model basic building blocks. An entity is a person, place, thing, or event about which data will be collected and stored. Business rule must be easy to understand and widely disseminated to ensure that every person in the organization shares a common interpretation of the rules. Business rules describe in simple language the main and distinguishing characteristics of the data as read by the company. The main sources of business rules are company managers, policy makers, department managers, and written documentation such as a company's procedures, standards, and operations manuals. A faster and more direct source of business rules is direct interviews with end users. Unfortunately, because perceptions differ, end users are sometimes a less reliable source when it comes to specifying business rules. The process of identifying and documenting business rules is essential to database design for several reasons. They help to standardize the company's view of data. They can be a communications tool between users and designers. For the designers, they will allow them to understand the nature, role, and scope of the data. They will also allow them to understand business processes. Lastly, they will allow them to develop appropriate relationship, participation, rules, and constraints, and to create an accurate data model. Business rules set the stage for the proper identification of entities, attributes, relationships, and constraints. In the real world, names are used to identify objects. If the business environment wants to keep track of the objects, there will be specific business rules for the objects. As a general rule, A noun in a business rule will translate into an entity in the model, and a verb which is active or passive that associates the nouns will translate into relationship among the entities. For example, the business rule "a customer may generate many invoices" contains two nouns, customer and invoices, and a verb generate that associates the nouns. To properly identify the type of relationship, you should consider that relationships are bidirectional, that is, they go both ways. For example, the business rule "a customer may generate many invoices" is complemented by the business rule "an invoice is generated by only one customer." In that case, the relationship is one to many, customer is the one side and invoice is the many side.
Hello guys, my name is Farris, and in this video I'm gonna explain about the types of data models. So there are mainly three different types of data models, and that is conceptual, logical, and physical. So for conceptual, this data model defines what the system contains. This model is typically created by business stakeholders and data architects, and the purpose of this data model is to organize and scope and define concept and rules. So there are three basic tenets of data models, that is entity, attribute, and relationship. Entity is a real world thing, for example human and object, and for attribute it is the characteristic of an entity, and the last is relationship. Relationship is the dependency between two entities. And then the characteristic of conceptual model. The first one is it offers organization-wide coverage of the business concept. The next one, this type of data model are designed and developed for a business audience. And lastly, the conceptual model is developed independently. Next, it is logical data model. So for logical data model, it add further information to the conceptual model elements, and it also defines the structure of the data element and set the relationship between them. At this data modeling level, no primary or secondary key is defined. You need to verify and adjust the connector details that were set earlier for relationship. For logical data model characteristic, it describes data needs for a single project but could integrate with other logical data model based on the scope of the project. And next one is designed and developed independently from the DBMS. Finally, normalization processes to the model is applied typically till 3NF. And for the last one is physical data model. A physical data model describes the database specific implementation of the database data model. It offers an extraction of the database and helps generate schema. This is because of the richness of metadata offered by a physical data model. This type of data model also helps to visualize database structure. It helps to model database column keys, constraint, index, triggers, and other RDBMS features. So for the characteristic of physical data model, the physical data model describes data need for a single project or application. It also contains relationship between tables that which addresses cardinality and nullability of the relationships. And finally, it is developed for a specific version of a DBMS.
So, for the ERD, also known as the Entity Relationship Diagram, the most important thing for this diagram is the entity, the attribute, the relationship, also known as the cardinality, and the constraint. So for the entity is also defined as any object in the system that is used to store information, whereas the attribute is a property or characteristics of an entity. So for the relationship, also known as cardinality, that is the one to many, many to many, many to one, and one to one relation. And for the constraints, there's a primary key and foreign key. So a primary key is a key in a relation database that is unique for each record, whereas a foreign key is a field in the table that is a primary key in another table. So for the example of an entity relationship diagram is shown here as the student registration system. So in this diagram, there are four entities, which are the subject, student, course, and teacher. For the student entity, it has four attributes, which is the student ID, also the primary key, the course ID, which is the foreign key because it's the primary key of the course, the student name, and student fees, and for the subject, it has two attributes, which is the subject ID, which is the primary key, and the subject name. And for the course entity, it has three attributes, which is the course ID, which is the primary key. That's why it's the foreign key for the student, and a teacher ID, which is a foreign key because it's a primary key for the teacher entity, and it has a course name. And for the teacher entity, it has three attributes, which is the teacher ID, teacher name, and teacher address. So in this diagram, it has a relationship, also like known as the cardinality, for like the relationship between the student and subject. For example, is that like it's a many to many relation, which means like many students can pick many subjects. And for the student and course relation, it's a one to one relation, which means that one student can choose one course. And for the course, it has a relation with the teachers, which means that the relation is a one to many relation, which means that one course can be taught by many teachers, and many teachers can only teach one course.